Number 5, it says three coplanar forces of magnitude 68 newtons, 75 newton and 100 newtons act at an origin O as shown. In the diagram, the coplanar forces of the component of three forces in the positive x direction are minus 60. Now when we look at these values minus 60, 0 and 96, we can pretty much see which force would correspond to these components. So this right here is 60 newtons, 0 is with the 75 in positive x direction because that is a perfectly vertical force, and with the 100 newton force I have this 96 newtons. Now the question says the components of the three forces in the positive y direction that needs to be found. So if I look at this 68 only, I have this 68, I have this 60, and I can apply Pythagoras theorem to find this y direction force. So 68 squared minus 60 squared whole square root gives me the later component, 68 square minus 60 square, and that is 32 newtons. So this right here y component is 32 newtons. Now for the 100 newton force, 100 squared minus 96 squared whole square root, I'm getting 28. So this component is 28 newtons. For the 75 newton, that is already in the y direction and complete 75. Second part of this question says the magnitude and direction of resultant of these forces. So as we discussed earlier, magnitude is sum of x forces, sum of y forces, and then we use the resultant and direction. So when I'm looking at the diagram, I can see that sum of forces in horizontal direction start with 96 minus 60 is 36 newtons, and when we talk about sum of forces in vertical direction, 75 is upwards, we normally take upwards and towards right as positive, and now we have two other forces which are downwards. So the resultant is 75 minus 28 minus 32 is 15 newtons. Now we can see that it is 36 newtons towards horizontal in positive direction and 15 newton in y direction, again positive, so it goes right and upwards. 36 and 15. To find the resultant, we use this formula, r equals square root x square plus y square and I'm getting 39 newtons. Now 39 is the resultant, and what is the direction? If we talk about this angle, that would be theta is equals to tan inverse y over x. And I'm getting 22.6. Now it is your choice, you write it as the direction is 22.6 with the positive x-axis, or we can write it is at a bearing of this is 90 minus 22.6, 067.4 degrees. Okay, the question says a particle P of weight 21 newtons is attached to one end of each of the light inextensible string S1 and S2 of length 0.52 meters and 0.25 meters. The other end of S1 is attached to fixed point A and the other end of S2 is attached to fixed point B at the same horizontal level as A. The particle P hangs in equilibrium at 0.2 meters below the level of AB with both strings taut as shown in the diagram. It says find the tension in S1 and S2. So as we can see, system is in equilibrium, that means horizontal forces, sum of horizontal forces is 0, sum of vertical forces is 0. Or we can say all the forces to left are equal to all the forces to right. So if I just consider this as theta 1 and this as theta 2, I can split them up. Using this S1, I can write this as S1 sine theta 1. And on the other side, I can say this is S2 sine theta 2. When we talk about the vertical components, I can say this one in blue is S1 cos of theta 1. And this vertical in green would be S2 cos of theta 2. Now before we write the forces, I'm just picking up few values. If I just look at this triangle, I know that this length is 0.52, this length is 0.2, and when we use Pythagoras theorem, 0.52 squared minus 0.2 squared whole square root, 0.52 square minus 0.2 squared, and square root of answer, I'm getting 0.48. This was the one with theta 1. On the other hand, I'm simplifying it so that would be quick when we solve. So this is 0.525, that is 0.2 already. So 0.25 square minus 0.2 squared whole square root. Thank you, that is 0.15. Now we can see a lot of theta 1, cos theta 1, sin theta 1 and 2's. So if I just extract them out, may I write as sin theta 1, I'm looking at the first triangle, and sine of theta 1 is perpendicular over hypotenuse, that is 0.48 over 0.52. 0.48 by 0.52 gives me 12 by 13. And same cos of theta 1 is base over hypotenuse, that is 0.2 by 0.52, and I'm getting 5 by 13. For the other triangle, sine theta 2 is perpendicular over hypotenuse, is 3 by 5, and cos of theta 2 is base over hypotenuse, is 4 by 5. The basic purpose of doing this is to get answer in exact form. Now we are starting, it is already in equilibrium, and we are finding the tension in S1 and S2. So if I look at the horizontal forces, I can say S1 sine theta 1 is equal to S2 sine theta 2, and I cannot see any other horizontal force. So force towards left is equal to force towards right. Now I know this is S1, and theta 1 is already simplified, which is 12 by 13. This is S2, sine of theta 2 is already simplified, sine theta 2, that is 3 by 5. So when making any one of these as subject, so S1 is equals to 3 by 5 into 13 by 12 of S2. That makes it 13 by 20 S2. This is S1. Now I'm making another equation using the vertical forces only, which is S1 cos theta 1, S1 cos of theta 1, that is upwards, and this force S2 cos theta 2 again upwards is equal to the only downward force, which is 21. Now meanwhile I copy the values of sin theta 1 and cos theta 1 and theta 2. I'm also replacing S1. So S1 is 13 by 20 of S2, whereas Cos of theta 1 is 5 by 13. S2 stays as it is, and cos of theta 2 is 4 by 5 is equals to 21. The only unknown in this line can be seen is S2. So 13 by 20 into 5 by 13. This is 1 by 4 of S2 plus 4 by 5 of S2 equals 21. So 21 by 20 of S2 is equals to 21, and S2 is equals to 20 newtons. S2 done. Now we can find S1. Bringing this equation down, S1 is equals to 13 by 20 of S2, where S2 is 20 newtons, and you get 13 newtons. The demand of question was to find the tensions, and these are your answers for S1 and S2. The only difference of considering these fractions and not considering it as such or replacing it, we can always find theta because we have all the lengths we need. That would be in decimals, and these answer you may get around 19 point something and or 20 point something. So that's the only difference. Question says a particle P of mass 0.5 kgs lies on smooth horizontal plane. If mass is 0.5 kg, weight would be mg. 0.5 into 10 is 5 newtons. Lies on a smooth horizontal plane. Forces of magnitude F Newton, 2.5 Newton, 2.6 Newton act on P. The direction of the forces are as shown in the diagram, where tan alpha is 12 by 5. If we have this, indirectly we have all the values. For example, if I draw and write alpha here, tan alpha is perpendicular over base. Applying Pythagoras theorem, I get 13. So I can actually write values for sine and cos as well. And tan beta is given, so this triangle is right there. Beta is here, tan beta is 7 by 24. So this is 7, this is 24. Applying Pythagoras theorem, I'm getting square root of answer, I'm getting 25. So we have all the values we need. Given that P is in equilibrium, find the values of F and theta. So if we resolve these forces, I have to resolve 3 of the forces. So 2.5, the cos component, the horizontal component would be 2.5 cos of beta. When we talk about this 2.6, the horizontal component is 2.6 cos of alpha. And when we talk about this F, this is F cos theta. Question says find F and tan theta. So this will give us one of the equation. So I'm writing all the forces towards left are equal to all the forces towards right. So F cos theta is towards left and the other two are towards right. 2.5 cos of beta plus 2.6 cos of alpha. Now we replace with all the known values. 2.5 from this triangle, I'm looking that cos beta is 24 by 25 plus 2.6 cos of alpha from the first triangle, that is 5 by 13. Using calculator to simplify, 2.5 into 24 by 25 plus 2.6 into 5 by 13, and I'm getting 17 by 5. So F cos theta, this is my first equation. Now I'm splitting them up in vertical. components. This is f sine theta upwards. This is again upwards, which is 2.5 sine of beta. This one is downwards, which is 2.6 sine of alpha. So now we adjust these three. Two are upwards and one is downward. So upward is f sine theta and 2.5 sine beta. F sine theta and 2.5 sine of beta, and downwards is 2.6 sine alpha. So f sine theta, now 2.5 sine beta from this triangle is 7 by 25. Is equals to 2.6. Sine of alpha is 12 by 13. So f sine theta is equal to 2.6. 12 by 13 minus 2.5, 7 by 25. Making use of the machine. And that is 17 by 10. I'm writing as 1.7. F sine theta. This one could also be written in exact form. 17 by 5 is 3.4. Now we have equation 1 and equation 2, and the demand of question was to find the values of f and tan theta. So if I just divide these two equations, dividing equation 2 by equation 1, so equation 2 is f sine theta is equal to 1.7, and dividing with the equation 1 is f cos theta, on the other side is 3.4. F cancels out, sine theta over cos theta is tan theta. That is 1 by 2. One thing, and now the value of force, we can use any of the equation. Let's say f sine theta is equals to 1.7, and we know that theta is equals to tan inverse of 1 by 2. That is 26.56. I'm using 26.6. is equals to 1.7. And F comes out to be 3.8 newtons. Second part of the question, the force of magnitude F is removed. Find the magnitude and direction of the acceleration with which P starts to move. So when F is removed, force F is removed, and force F we can see was 3.8 newtons. So basically this is in equilibrium, but when F is removed, equal and opposite, we will have some net force, and that is equal to F, which is 3.4. For second part, I can say F equals ma, and net force is 3.8. Mass is given in the question, and acceleration would be 3.8 divided by 0.5 is 7.6 meters per second square. And direction, we already know what this theta was representing in this question. See, this is theta. So direction would be, when this is removed, direction would be exactly opposite of this. So first I'm finding this theta using the equation tan theta is equals to 1 by 2. So tan theta is equals to 1 by 2. Theta is equals to tan inverse of 1 by 2, and I get 26.6 degrees. Now see, this was force F, which was 3.8 newtons, and this was the angle 26.6. Now when this is removed, net force is opposite to that, and this is the angle where it would exert that reaction force. So now we can say either 26.6 with positive x-axis or below that as shown in the diagram, or I can say it is at a bearing of, now this is 90 plus 26.6, it is at a bearing of 116.6 degrees. Any questions? Question says A and B are fixed points on the vertical wall with A vertically above B, as we can see in the diagram. A particle P of mass 0.7 kg is attached to A by a light inextensible string of length 3 meters. P is also attached to B by a light inextensible string of 2.5 meters. P is maintained in equilibrium at a distance of 2.4 meters from the wall by the horizontal force of magnitude 10 newtons. So I am just drawing this force, that is 7 kg, 0.7 kg, so it would become 7 newton. Now the question says both strings are taut and 10 newton force acts in the plane APB, which is perpendicular to the wall. Find the tensions in the strings. So we are resolving, and I know we would need some values. I'm writing it as alpha and beta. Let's say this is beta and this is alpha. Or let me take it on the other side, because these lengths are known. Let's say this is alpha and this is beta, and I'm applying Pythagoras theorem to find these lengths in case I need it. So 3 square minus 2.4 square square root answer, I'm getting 9 by 5, that is 1.8. Now the other one, 2.5 square minus 2.4 square root answer is 0.7. So we have all the lengths, that means we have sine cos tan. And in order to find the tension, let's say this is T1 and this is T2. So if I resolve T1 in horizontal direction, that is towards left, this will be T1 cos of alpha. Again resolving T2, that is towards left, is T2 cos of alpha. Cos of beta is equals to the only force towards right, that is 10 newtons. Replacing all the known values, this is T1 cos alpha is 2.4 by 3 plus T2 cos beta is 2.4 by 2.5 is equals to 10. Simplifying, 2.4 by 3 is 0.8, 0.8 T1 plus 2.4 by 2.5 is 0.96 of T2 is equals to 10. So this is equation 1. Equation 2 would be all the verticals, and if I see a T1, only T1 is upwards, all the other forces are downwards. So T1 Sine of alpha is equal to T2 sine of beta plus 7, which is also downwards. So looking at the same triangle, T1 sine of alpha is perpendicular over hypotenuse 1.8 by 3 is equals to T2 sine of beta is perpendicular 0.7 by hypotenuse is 2.5 plus 7. So 1.8 by 3 is 0.6. T1 is equals to 0.7 divided by 2.5 is 0.28 of T2 plus 7. This is equation 2. Now we can use any equation to make one of the subject and solve for T1 and T2. I'm using the second equation. T1 is equals to dividing with 0.6 on the other side. 0.28 divided by 0.6 is 7 by 15. T2 plus 7 divided by 0.6 is 35 by 3. Replacing this T1 in the first equation, 0.8 of T1, 7 by 15 T2 plus 35 by 3 plus 0.96 of T2 is equals to 10. I'm multiplying this 0.8 inwards. 0.8 into 7 by 15 gives me 28 by 75 of T2. 35 by 3 into 0.8 gives me 28 by 3 plus 0.96 of T2 is equals to 10. Now I'm adding these two directly. 28 by 75 plus 0.96 gives me 4 by 3 of T2, and I'm subtracting this on the other side. 10 minus 28 by 3, I'm getting 2 by 3. So T2 is equals to 2 by 4 and T2 is equals to 0.5 newtons. Now for T1, so T1 is equals to 7 by 15 of T2 plus 35 by 3. 7 divided by 15 into 0.5 plus 35 by 3, that is 119 by 10 equals to 11.9 newtons. Clear?